Okay, the second part of today's video is going to talk about DNA fingerprinting. So how can we use restriction enzymes to identify our human DNA? Okay, so everybody's DNA has different sequences. So if you look at individual one's DNA versus individual two, you can use the same restriction enzyme. Remember that nuclease that cuts at specific locations? Well, within a certain sequence of DNA, everybody's restriction site or where the restriction enzyme is going to cut is going to be different. That's going to result in different fragments. Okay, so you can see there's 3 cuts on individual 1. That means they're going to end up with 1, 2, 3, 4 fragments. Individual 2 only had 2 sites where the restriction enzyme could cut, so it's going to result in 3 fragments. Okay, so we can take anybody's human DNA and cut it with restriction enzymes and get different fragments. So then how are we going to use those fragments? Okay, what we're going to do is run it through a process called gel electrophoresis. Okay, so it's a gel. Okay, it's made up of agarose, which is like a kind of like a jello. And then we're going to use electrophoresis. If you remember, DNA is super, super negative due to the phosphate sugar backbone. So the phosphates are really, really negative. So we're going to use electric charges to make the DNA attract. Okay, so if DNA is negative, they're going to put a negative charge here and a positive down here, and the DNA is going to move. Okay, now depending on the size of the fragment, just like anything smaller is going to move faster than anything that's larger. So the fragments at the bottom are smaller, the fragments at the top are larger. Okay, so just like I just stated, gel electrophoresis separates DNA based on size. Okay, so it runs through a gel which is made of agarose. If you remember, ose is a sugar. Okay, it's made from a seaweed. Okay, and we're going to use DNA charge of negative of that phosphate to move the DNA fragments. Okay, so you're going to do an animation tomorrow instead of doing the real lab. Sorry, guys. So you'll get more details of this. There's also a video linked in your notes if you want to watch that. But why do we use gel electrophoresis? Okay, the 2 biggest are for paternity tests and then for forensics cases. Okay, so paternity tests, you remember you get half your DNA from your mom, half your DNA from your dad. Okay, so you can actually look at the genes and look at the bands to figure out who the dad is. Okay, and then forensics, we can take a blood sample or any other bodily fluid that has cells. We can extract the DNA and we can take a cheek swab sample. You've probably seen that on crime shows to match the DNA. So it's a little bit more valid than actual fingerprinting. This is called DNA fingerprinting. Okay, so if you look at, the child, and here's the mom, and then you have the 2 dads. So you would just look at the banding pattern to see which one is the father. So we have bands here that match up. Okay, we have a child here, and look, mom didn't give those bands, but male 1 did give the bands. So to have a child, you're going to have half the DNA from mom, half the DNA from dad. Male 2 did not contribute any of his DNA, so the father is male 1. Okay, if you go over here to forensics, this is the ladder. This is used so we can figure out the size of the fragments. This is our DNA from the crime scene, and we have our 3 suspects. Okay, so the blood or sample from the crime scene only resulted in 1 band. Okay, so it could be suspect 1, but it's a little bit bigger, so that's not it. Suspect 2, there's a band, but there's 2 when it was cut restriction, so it can't be suspect 2. Suspect 3 had the same size fragment and only 1 fragment, so suspect 3, committed the crime in this case. Okay. This is what a real gel looks like. Okay. So it's not as pretty as like the clean lines. So you can do this one on your own. You have the defendant's blood. Here's the jeans, the t-shirt, and then the victim. So you can actually figure out if he or she did the crime. Okay. So tomorrow you're going to be doing an animation with this. So hope you enjoy it. Have a good Monday.